So this is the beginning of Unit 4, which includes the introduction to sequences and series and sigma notation. We'll discuss geometric series and sequences, arithmetic sequences and series, as well as word problems that deal with the two. So first, just a quick introduction to sequences and series and sigma notation. So we see that a sequence is a list of a pattern in a certain order, where each part of the pattern is called a term. So for sequence notation, we use subscripts to denote which term it is in the sequence. So we have a sub 1, a sub 2, a sub 3, all the way up to a sub n, where a sub 1 is our first term, a sub 2 is our second term, a sub 3 is our third term, and a sub n represents the nth term. So sequence representations, there are three ways that we represent sequences. The first, we can use pictures. As you notice, the red dot keeps moving around. So as we complete this sequence, it changes to being the fourth place and then to the fifth place. The next sequence is in words, applying, bathing, cuddling, and the sequence that we're looking at is it's in alphabetical order, A, B, C, but it also ends in ing. So a couple of more words that you can use is ducking, eating, or ending. And the next way that we use sequences is in numbers, and this is what we'll focus on with this lesson is in numbers. So 3, 10, 24, 45. The sequence that we have here, what is happening as we move from 3 to 10, 10 to 24, 24 to 45? If you notice that it's multiples of 7 that we're adding. So we add 7 to 3 to get 10, add 14 to 10 to get 24. So we would add 21 to 24 to get to 45. And so we would add 28 to 45 to get to 73. And then we would add 35 to 73 to get to 108. So using that idea, the example says find the first three terms and the 200 term, write the final answer as a sequence. So n represents the term number. So if I want to find the first three terms, I'm going to let n equal 1. So a sub 1 equals 7 times 1 plus 2, which in turn gives me 9. A sub 2 equals 7 times 2 plus 2, which in turn gives me 16. A sub 3 equals 7 times 3 plus 2, which is 21 plus 2, which gives me 23. A sub 200 equals 7 times 200 plus 2, which is 1402. So if we were to write this out in our sequence order, we would say 9, 16, 23, and 1402. So for the next one, we would do the same thing. So for this next problem, we would do the same process, let n equal 1. So a sub 1 equals 1 squared minus 3, which gives us negative 2. For the second term, we let n equals 2. 2 squared minus 3, which in turn gives us 1. So the third term, a sub 3, 3 squared minus 3, that equals 6. And the 200th term is 39997. So our sequence becomes negative 2, 1, 6, dot, 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 3997. Yes, it is important that you put the dot, 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 because that implies that there are values in between those two numbers that will fill in the remaining portions of the sequence. So we'll look at the next one. 2n divided by n plus 5. So we let n equal 1. And you get 1/3. N equal 2. You get 4 over 7. N equal 3. And you get 3 over 4. And a sub 4 A sub 200, excuse me. You get 80 over 41. So our sequence is 1/3, 4 over 7, 3/4, and then 80 over 41. So that is the idea of what a sequence is. So a recursive sequence is a sequence that uses a previous term to get to the next term. So what you want to look for is the a sub n minus 1. Anytime you see that, or a sub n plus 1 equals a sub n, that implies that we're looking at a previous term. So if we're given this equation, a sub n equals -2, a sub n minus 1 plus 6, where a sub 1 equals 5. Typically, when you have a recursive sequence problem, they're going to give you the first term or a term to use to begin your sequence. So being that we're trying to find the first 4 terms, we already have the first one, so we want to know what a sub 2 is. That equals -2, a sub 2 minus 1 plus 6. So if we simplify this, it's -2, a sub 1 plus 6. Well, we know what a sub 1 is. It equals 5. So we're going to replace that with 5. And that gives us -4. So now we want to find the third term. A sub 3 minus 1 plus 6 equals, simplify that, -2, a sub 2 plus 6. Well, we know a sub 2 because we just found it to be -4. So now we'll plug that in, -2 times -4 plus 6. And once we do that, we get 14. A sub 4, -2, a sub 4 minus 1 plus 6. It's -2, a sub 3 plus 6. And we know a sub 3 is 14 because we just found it. So we plug that in, and we get -22. So our sequence is 5, -4, 14, -22. Okay, for the next one, we are given that a sub 1 equals 8, and we have a sub n plus 1 equals 3 times a sub n minus 2n. So we want to know the second term. So that's going to be a sub 1 plus 1 equals 3, a sub 1 minus 2 times 1. And that gives me a sub 2 equals 3 times 8 minus 2, which equals 18. So now that we know that a sub 2 is 18, we can find the next one. So a sub 2 plus 1, which is a sub 3, equals 3, a sub 2 minus 2 times 2, which equals 3, 18 minus 4, which is 14 times 3, which is 42. So we do the same thing. A sub 3 plus 1, which gives me a sub 4, equals 3. A sub 3 minus 2 times 3 equals 3 times 42 minus 6, which gives me 108. So my first 4 terms are 8, 18, 42, and 108. One thing to notice and to pay attention to, you have a sub n plus 1. So if you're trying to find the second term, n has to be 1 because it gives you 1 plus 1, which is 2. That's how we get the second term. So pay close attention to that, because even though both of these, n plus 1 and n minus 1, signify that you are going to use the previous term in some way, we're using the previous term in different ways in these two problems. So make sure you pay close attention to that. Okay, so for a series. A series is the indicated sum of the terms in a sequence. So to distinguish the difference between a sequence and a series has commas and a series has the addition symbol. So the series notation, capital S sub n, is the sum of n terms, where we have a sub 1 plus a sub 2 plus a sub 3, all the way up to a sub n. That is the sum of the first n terms through the nth term. So if we want to find the series, that means we're going to add up all the terms in that particular sequence. So for this particular problem, it says find the sum for the given sequence. And the sequence is a sub n equals 2n plus 6. It tells us to find s sub 4. In order to find s sub 4, you need the first 4 terms, because that's what the 4 stands for. So a sub 1 equals 2 times 1 plus 6. And a quick way to do this is to use your calculator. That equals 8. A sub 2 is 10. A sub 3 is 12. And a sub 4 equals 14. Doing it in your calculator, all you have to do is type 2n plus 6 into the y equals, and then you can look at the table of values for 1, 2, 3, and 4 to find out what they equal at those given values. So if we wanted to add all these together, we would have 8 plus 10 plus 12 plus 14. And that total gives us 44, and that's my answer. So for the next one, this one says find the sum of the first 3 terms. So 6 times 4n, minus 2 squared. So we'll find a sub 1. Again, put it in your calculator in your y equals, and at 1 it equals 24. A sub 2 equals 216. A sub 3 equals 600. A sub 4 equals 1176. Okay, now that we have all of our first 4 terms, we want to simply add these together. Actually, we only needed 3 of them, so we're going to take that one off. So 24 plus 216 plus 600 equals 840, and that's my answer. So another way that we can talk about series is through sigma notation. It's a less lengthy and more concise way to write out a series, and the following is a simple representation of sigma notation. And we know that the sigma, this is a capital sigma, and it's a Greek letter, and it represents the sum. So the very bottom number, n equals 1, is your starting place, and the very top number, 4, is where it ends. So we're going to look at the first term through the 4th term. So we'll plug in the equation, is 3n that we're using. So we'll plug in n equals 1, 2, 3, and 4, and add all those values up, and we get s of 4 equals 30. So in order to do this, I really would rather you guys use the calculator for these, because these problems can be long if you try to write them out. So what we want to do, if you look in your calculator and you go to math and you come down to 0, it gives the summation. So you're going to use the variable x instead of n. So we'll type in x equals 1, the top number 3, and the equation 5x minus 4, and it'll give you the answer equals 18. If I was to write this out by hand, it would be 5 times 1 minus 4 plus 5 times 2 minus 4 plus 5 times 3 minus 4, which will in turn give you 18. Using the calculator is quicker and it's more effective. So again, so you hit math, here are your steps, come down to summation, and I think it's 0 is the letter. So it will give you a summation symbol. A box here equals a box, and then another box, and then it'll give you a box as well. So for this box, this is where your variable goes. So we'll let that be x. Here is your starting number, so that will be 2 for this example. And here you will put 6. Inside this box, you're going to put 4 to the n plus 3. And then you just simply hit enter, and it will give you an answer to this problem. So this one actually equals 5471. So I suggest you use the calculator for those type of problems. So the next type is to given a written out series, rewrite it using sigma notation. So this can be a bit tricky because you have to identify what pattern is happening, and you have to write an equation for that pattern. So looking at the first example, we have 1, 4, 9, and 64. Notice that these numbers are perfect squares. So if you want to know the pattern here, it's just simply n to the second, because 1 squared is 1, 2 squared is 4, 3 squared is 9, and all the way up to 8 squared, which is 64. So we would sum all those together, and we let n equal 1 to start, and n equal 8 to end. And that gives us our sigma notation for that series. Example B, notice that these are just even numbers, 2, 4, 6, all the way up to 26. So there are two ways that we model even numbers. Well, one way. And we can just call it 2n. Odd numbers are modeled as 2n minus 1 or 2n plus 1. So for this one, we have sigma 2n, n equals 1 because 1 times 2 is 2, and the last one is 13 times 2, so our top number would be 13 because that gives us 26. The next set is 1, 3, 5, and 11. These are our odd numbers, so we'll use 2n minus 1. We'll let n equal 1 to begin with, and so all the way up to 11, so that means it would have to be 6 as our top number because 2 times 6 is 12 minus 1 gives us 11. All right, example D. So you have 139 up to 729. So look at what's happening. 139, these are not just odd numbers, but they're multiples of 3. So if we look at it, 3 to the n power minus 1, 3 to the n minus 1, because we want our sigma notation to start at 1 if we can help it. We don't really want it to start at 0. We really want it to start at 1. So if we let it start at 1, then we get 3 to the 0, which gives us our first term of 1. If we let n be 2, it gives us 3 to the 2 minus 1, which is 3 to the first, which is 3, and so on and so forth. Well, we know that 3 to the 6 is 729, so that means we need to let our top number be 7 to get 6 as our exponent. And that's how we write that equation. The next one is E. Is 15, 20, 25, all the way up to 45. Now these are just multiples of 5, so we can just simply say 5n. And we can start n at 3 because 5 times 3 gives us 15. And we will end this at 9 because 5 times 9 is 45. And finally, example F, 16, 64, 256. What are these multiples of? They're 4 to some power. So we'll say 4 to the n. So, but notice something is happening. The signs are going to be changing. They're going to be alternating. So we have to make sure that we account for that. So this is going to be negative 4 to the n power. So when it's an even exponent, it's a positive number, but an odd exponent, it produces a negative number. So our first n will be 2 because negative 4 squared gives me 16. And finally, it'll go up to 6 because 4 to the 6th power produces 4,096. And so that's how you properly write out these in sigma notation. The key to doing the sigma notation is to make sure you understand how to write the equations from the given series. That's the important thing, and that is the difficult thing. So you will have to practice on that to make sure you are familiar with those types of equations.